In this demonstration, you'll learn about the simulation workflow in AIM. We'll walk through a structural simulation of the effects of temperature inside a manifold. To start, we'll choose a template that matches the physics we'll be solving, the structural template. Select Thermal and keep all other defaults. Click Create Simulation Process to get started and import the geometry file. The simulation process is made up of distinct but connected steps. AIM calls these tasks. The template creates the tasks of your simulation shown in the summary grid and in the Workflow tab of the View panel. Each task is a connected step in the simulation process. Click on the task to open that task's data panel. Each task is a container for all of the objects and settings within that step. Although the starting template adds objects and default settings, you can change any of these to match your specific simulation. If you have questions as you move through the workflow, clicking on question marks will open different kinds of help. Let's start setting up the simulation. Because I enabled model editing, the geometry task is where I can edit the geometry file. Here you can modify an imported geometry or even create a new geometry. Return to the physics simulation by clicking here. Next is the mesh task. Let's review the setup in the mesh data panel. How fine do we want the mesh to be? A good strategy, especially for larger models, is to begin with a lower mesh resolution that calculates quickly and then, if needed, solve again with a higher mesh resolution. You can always come back and refine the entire mesh or add controls to refine specific areas of interest. Updating the mesh task generates the mesh. Now let's look at the physics task, the next task in the workflow. Here, we set up and solve the physics solution. Again, all of the objects and settings defined by the template can be modified for your own requirements. In the physics task, the physics region defines the physics being solved, in this example, structural. The location field shows that all bodies in the model are part of this physics region. There are visual cues and messages to help you set up tasks. Attention required means that objects are missing or need information before you can update this task. The Messages tab summarizes the changes needed. Here's a blue color cue to add structural conditions. You can add objects here in the data panel. Let's add supports to the openings of the manifold using the Face Selection filter. Use the Control key to select multiple locations at once. To add faces or change a location, select the faces you want to include, edit the supports, and add or replace the faces. Right-click to add a temperature condition and apply it to a selected set of faces on the inside of the manifold. The location is listed when you click inside the field. Let's confirm that the material is structural steel. We can also realistically render the model using the enhanced display. Solve Physics runs the calculation and updates the physics task. Information about the solution is in the Transcript tab. With the physics solved, you can visualize the simulation in the Results task. The template automatically adds 3 results, but they have to be updated before you can visualize them. You can add more contours, calculated values, isosurfaces, or vectors to review the variables of interest. Now, updating the Results task evaluates the results. It's easy to animate any of the results and view them simultaneously. We've now completed a simulation in AIM. Once you've reviewed these results, you may want to make refinements or changes to the physics setup, the mesh, or the model, and solve again. This concludes Part 1 of Getting Started with AIM. In Part 2, I'll show you more about the AIM workspace.